So Galileo, everyone's heard of Galileo, right? He's pretty darn famous. So he is actually the fourth person in kind of this chain of the Copernican revolution. We had Copernicus, Tycho Brahe, Johann Kepler, and now we have Galileo Galilei. So the thing about Galileo is that he kind of came up with even more reasons why this heliocentric or sun-centered model of our local address is correct. So things that he actually was able to address, and I have slides coming up to kind of show you. Okay, but things he addressed, the first thing was that basically people who oppose the idea that the Earth orbits the sun says, hey, if the Earth were moving, actually what would happen is because it's moving, everything, objects on the Earth, like our air, not to mention our birds, anything that left the Earth actually would be left behind in Earth's dust as Earth orbits the sun. So we're going to address that. Of course, that sounds silly to us now, but and then the second item there, actually he was up against the prevailing thought that anything beyond, anything in our heavens, which would be like Earth's atmosphere and beyond, it was perfect. It was totally perfect. So he kind of came up with some ideas about the reason that actually there are things that it's wonderfully awesome, but it's changing. It's not always the same. And actually this actually would go along with switching from the perfect circular orbit to the elliptical orbit, which was Kepler's first law. So last but not least was this kind of reoccurring thing about parallax. Remember what parallax is it says that basically we know that if you kind of move back and forth, relocate you as the observer from one position to another position, actually nearby objects will look like they're in a different place against the background objects. And so people that opposed this sun-centered model of the Earth orbiting the sun said that as the Earth moves in its orbit, we're going to see kind of like the stars basically kind of scramble their position because of parallax. And Galileo was able to address that too. So meet Galileo. So one thing about it is sometimes, as famous as Galileo is, we think that Galileo invented the telescope. I run into that all the time. Actually, the telescope had already been invented, but had been mostly used, had been used for land objects, such as like pirates using telescopes, that sort of thing. He was the first one to notably use it in the scientific study of the celestial objects, okay, of the stars and such. So, all right, so the first objection that actually as the Earth moved in its orbit about the sun, that the birds and the air and anything that like jumped off the Earth would be left behind. He did some of his own experimentation, which I think is kind of cool, and that he said that if an object was in motion, so let's say those birds are in motion as they leave the Earth's surface, actually they're going to stay in that same motion unless they're acted upon by an outside force. This is sometimes called the law of inertia. So basically he said that Galileo said, don't worry about it. The Earth can orbit the sun and things that leave the Earth's surface will stay, continue in their same movement as they were when they were part of the Earth. So let's see, that's Newton's first law of motion. The next objection, he said that, with regard to the heavens being perfect and they cannot change, I wouldn't call them necessary blemishes, but I suppose you could. Actually, he saw sunspots or blemishes on the sun. The other thing is that those are irregularities, thus things in the heavens are not perfect. He also saw irregularities on the moon. Okay, of course, we kind of see even with the naked eye some irregularities. The dark spots are called mare. The light regions on the moon are the highlands. So he said, look, don't get hung up on this going to a sun-centered model and making the shape of the orbit elliptical from circular. Don't get hung up on circles are perfect, because the heavens must be perfect. So what else? Third one, with regard to parallax. So remember, parallax only works if an object is relatively close. So Actually, we do detect parallax in stars. That's one way we can determine how far away that star is, if we see parallax as the Earth changes its position and orbiting the sun. But parallax breaks down, or you do not see parallax if an object is so far away. So one of the things that Galileo did with his telescope was that he looked up at the Milky Way. And I would suggest, if you have a pair of binoculars, you're out sometime, you have a telescope, you're out sometime, just look at the Milky Way and see what Galileo saw. And you're going to see, instead of kind of just like what looks like a cloud pieces, okay, like a haze, is actually tiny little stars. It's wonderful. And he said, you know what? The reason it looks like tiny pinpoints of light is they are, it's so far, those stars are so far away. So he said they're too far away to exhibit parallax. A few other things that Galileo observed that was helpful in understanding our local neighborhood. Over here on the left, we see this right here. Is this not cool? I think this is kind of an image of what his notebook looked like. Let me kind of zone in. Okay, that circle there is Jupiter, and those things that look like stars are actually things that he observed orbiting Jupiter. So those are actually moons that orbit the planet Jupiter. And they are called, nowadays, we generally call them Galilean moons. So these are the Galilean moons. Sorry if my spelling is terrible. Okay, so he noticed that, and he was like, hey, you know, if actually planets can have things orbit them, okay, so I think it's safe leap to make the correct leap that actually the planets are orbiting the sun. The other thing that he saw, which is so amazing, I think, he saw this over here, okay, the Copernican view of Venus. Notice it's called the Copernican view because we have the sun, and we have Venus orbiting the sun, and we have, of course, the Earth orbiting the sun. So if we put the sun in the center of our motion and motion of Venus, actually Venus sometimes goes through a new phase, okay, where the lit part, actually we don't see any of it. Okay, then actually Venus will go through a crescent, waxing quarter, gibbous, and over here I know we can't see Venus because like Venus is behind the sun there, right? But Venus would be in its full phase as seen from Earth. Okay, then it would be a waning gibbous, waning quarter, and a crescent. So this only works with a sun-centered or heliocentric model of our local solar system. So just to kind of finish up Galileo, there are books out there about him. He must have been quite the dynamic guy. He did write his own book, but he definitely went through his own trials. I think he did. I'm sure he published. You can see that actually what he was proposing as part of the Copernican revolution, removing Earth from the center of kind of the universe known at the time, was blasphemous to the church. And so he was thrown in, I think, under house arrest for kind of the last part of his life. But he was vindicated in 1992.